Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over the titration of a strong acid with a strong base. And so just to recap what a titration is, remember that titration is where you are basically adding one substance to another to neutralize it. So in an acid-base titration, you might start with an acid in your Erlenmeyer flask, and then in your burette, you have your base, and you're adding the base to the acid until it's neutralized. Normally, you will have some sort of indicator in your Erlenmeyer flask, so that you'll get some sort of color change when you reach the end point of your titration. And in a titration, we're trying to get to what is called the equivalence point. The equivalence point of a titration is where the moles of acid added, or that you start with, is equal to the moles of base added. So here in this problem, we're starting with a strong acid, and we're going to add strong base to the acid. And then when we get the equal moles of those, where the number of moles of acid we begin with is equal to the number of moles of base added, then that would be the equivalence point of the titration. And that's normally where you stop. Okay, so in this particular video, I'm going to go over the titration of a strong acid with a strong base, and we'll work out the titration curve. Here is the graph paper, if you will. And so I have down here volume of NaOH added in milliliters. So your titration curve is given in pH versus the volume of either your base or acid, depending on what you are titrating. So since we are titrating a strong acid and we're going to be adding a strong base, so we're going to measure or record the volume of the base added and the pH of the solution as we're titrating. Okay, so so where do we begin with? So we're going to first calculate the volume of the NaOH that we need to reach the equivalence point. So since we know that at the equivalence point, the number of moles of acid that we begin with must be equal to the moles of base that we are adding, then all we need to do is figure out the volume by using your molarity definition, right? So since we're given 25 milliliters of our acid. So here's our problem. We're given 25 milliliters of a 0.100 molar acid, HCl, and we're titrating that with 0.100 molar NaOH. So we need to know the volume of NaOH we need to add in order to get to that equivalence point. And again, the equivalence point is where the moles equal each other. So since we're given the volume of our strong acid and the molarity, then we can use the molarity as a conversion factor to convert milliliters to moles. So let's do that. So we're given 25 milliliters. We're going to have to convert that to liters. So that's going to be 0.025 liters of our HCl. So that's going to be liters of our HCl solution over 1. And then we're going to multiply that by our molarity. So that's 0.100 moles per liter. So we're going to write 0.100 moles of HCl, and that's going to be over that's going to be over 1 liter of the HCl solution, and then the liters of HCl cancel out. So then all we need to do is multiply this by this, and we get 0.0025 moles of HCl. So this is the amount of HCl we are starting with. So that means at the equivalence point, that it must be the number of moles that must be added of our NaOH. So since this is the number of moles that we need to add from our NaOH solution, now we can use this to figure out the number of the volume of base we need to add. So since they give me the molarity of the base, and now I know how many moles of the base I need to add, then I can use this to figure out the volume. So I'm going to start with this amount. So it's going to be 0.0025 moles. This time it's moles of NaOH over 1. And so now that I have my moles of NaOH, I need to convert that to volume. So I'm going to use my molarity. And so I'm going to, again, use molarity as a conversion. So again, this is 0.100 moles per liter. And so since I have moles here, then the moles are going to go on the bottom, 0.100 moles of NaOH. And then I have 1 liter of NaOH solution on the top. So moles cancels out. And then now I'm dividing this by this, and that's going to be equal to 0.025 liters of my NaOH solution, which is the same as 25 milliliters of NaOH solution. So in order to neutralize my strong acid I'm given, in order to neutralize 25 milliliters of the 0.100 molar HCl solution that I'm given, I need to add 25 milliliters of the base. And that makes sense because the concentrations of the two solutions that I am adding together are equal. So that would mean that the volumes must be equal as well. So the volume that I must add to neutralize the acid is equal to the volume that I start with for the acid. So if these concentrations were different, then the volume of the base I would have to add would be different from the volume of the acid I am starting with. But since they're the same concentration, then the volumes are going to be the same. All right, so now that I have my volume of acid, so this is the volume, this is the volume of the base I have to add in order to reach the equivalence point of my graph. And again, the equivalence point is where the moles of base I added is equal to the moles of acid I started with. Okay, so now that we have this, we can go to step 2. So now step 2 is where I need to calculate the initial pH of the solution before I add any base. So at this point, once you've figured out the volume of base you need to reach the equivalence point, now I'm going to show you how to calculate the pH at various stages of the titration. So at the very beginning of the titration, before I add any base, we can calculate the initial pH of the solution. Since our solution that we are starting with is a strong acid, then that means that the H plus concentration is going to be equal to the concentration of the acid itself. Because remember, a strong acid is going to ionize completely in water, where it's 100% ionization. So all of the molecules of HCl will ionize into H plus and Cl minus. And so whatever concentration of the strong acid we start with, that's going to be this concentration of the H plus in solution. So all of our acid is ionized into H plus. So here we have 0.100 molar HCl. So therefore we have 0.100 molar H plus. And so using that, I'm going to erase this since we've got our volume. So we need 25 milliliters to reach an equivalence point. So I'll write that up here. So 25.0 milliliters. So that's the volume of base we need to reach the equivalence point. And since I want to calculate the initial pH of my HCl solution, I'm going to use the pH is equal to the negative log of the H plus concentration. Since I know that for a strong acid, the concentration of HCl is equal to the concentration of H plus in solution, and I know that pH is equal to the negative log of H plus concentration, then I can put that in there for the H plus concentration. So this concentration is 0.100 molar, which is the same as the H plus concentration. So that's going to be negative log of 0.100, and again that's going to be pH of 1. So that is the pH of our strong acid solution before we add any strong base. So on my graph, this is going to be 0 and 2, so the pH is in the middle right here. So somewhere close to there, so that would be pH of 1. So let me make that bigger so it's clear. So my pH of 1 is there, and so that is the initial pH. So that's part 2. So now the next thing I want to do is I want to calculate the pH after adding a little bit of my strong base. So let's say 5 milliliters. So whenever you add a strong base to a strong acid, that's going to react completely. So this is a stoichiometry problem. It's not an equilibrium problem. So we're not going to do any ice table. So we need to do a stoichiometry problem here. So we'll have to do our ICF-like table. So we have our H plus our OH minus, and that's going to go to water. Okay, so you have the before adding anything, right? So here's our table. So before we add anything, when we're going to add our base, and then after we add our base. And so we're going to ignore water here. So before we added anything, we have 0.100 molar HCl. So when we do this, remember you got to convert everything to moles first. So you can't put concentration here, you got to do moles. So at 25 milliliters, using your molarity, just like we did before, we can calculate the number of moles of our HCl. So here we can do, we have, again, we calculated that earlier before, so the number of moles that we start with here is 0.02, oops, forgot a 0. 0.0025 moles. So that's the number of moles of the acid that we have. So H plus. So this is the moles of H plus that we have. And what we start with, we have 0. Start with 0 OH minus. So although there is some OH minus, because we got to consider the auto ionization of water, there is some OH minus in there, but we're effectively 0 for OH minus. And then at 5 milliliters, well, how many moles was added? How many moles of our OH minus was added with 5 milliliters? So we take the molarity again, and we calculate the number of moles of our NaOH. So that's going to be 5.00. Oops. We want to convert that to liters. So that's going to be 0.005 liters over 1. And then we have the molarity of our OH concentration. So that's going to be 0.100 moles of our NaOH. And that's going to be over 1 liter. So liters cancels out. And so what we end up with is 0.0005 moles of our NaOH. So now that we know the moles of our NaOH that we're adding, we can write that here. So we're adding 0.0005 moles of the NaOH, and so we're not adding anything there. So then the question is then, what's left? So here we have our H plus, oops, I wrote this in the wrong place. This should be the amount of OH added, so that's 0.0005 moles. And so we added OH, not H. So we added moles of our OH here, and since we know that that this is going to be a complete reaction, all of the OH minus is going to react with your HCl, your H plus. And so since we have this many moles of H plus, we have this many moles of OH, so all of this is going to be reacting. So this is going to go to 0. So we're going to end up with 0 again. So that means this is minus 0.0005 moles. So we lose that, becomes 0. Since this is reacting completely with the acid, then we're losing 0.0005 moles here. And that leaves us with 0.0020 moles of H plus. So now that we have this as our H plus that's left over, we can calculate the pH of the solution after the reaction of the base. So just like we did before, so pH is equal to the negative log of the H plus concentration. What we need to then keep in mind is you can't put the moles into the equation because this is H plus concentration. It's not moles, it's concentration. So you got to be careful because first, you can't put moles in there, but second, you got to recalculate the molarity. And you have to be careful because you added more volume. So we started off with 25 milliliters, but when we added 5 milliliters of our NaOH, we've changed the volume. We now have 30 milliliters of our total solution. So we need to take the moles here and divide it by the new volume of 30 milliliters, or 0.003 liters. So then what we do here first is we must recalculate the molarity of our new solution after adding the 5 milliliters of NaOH. So then we take the 0.002 moles of H plus that are left over, and divide that by 0.003 liters. And then we get the new concentration, which is going to be, let's see here. So the new concentration is 0.002 divided by 0.003 equals, and that's going to be 0.6. Hold on a second. That's not right. Okay, so I see my mistake. So I made a mistake. I added too many zeros here. So that should be a 3 there. Where'd my marker go? Here we go. So this is going to be 30. Yeah, that's better. So then let me calculate this again. So 0.002 divided by 0.03 equals, yeah, that's better. That makes sense. So we'll get 0.06 and so on. So this is our new molarity. So that's the molarity of our H plus concentration after adding your 5 milliliters of the strong base. So then what we do is now we can put this, now we can take this concentration and say pH is equal to the negative log of 0.066666. And so when we take the negative log of that, so that's going to be, so that's going to be, take the log, and that means that our new pH is now equal to 1.18. So 1.18 is the new pH after adding 5 milliliters of our strong base. So now if I put the new point here, this is 1. So now we're at 1.18. So maybe it's slightly higher. So maybe it's there, slightly higher. So now, what do? So the next thing is we can do the same thing. It's like this is, oops, I forgot. This should be 4, 5, 6, 7. So at step 4, we can calculate the pH of our solution after we add 10 milliliters, 15 milliliters, and 20 milliliters, doing the exact same thing we did here. So instead of, if at 10 milliliters, I would use the 10 milliliters of the base and then calculate the number of moles, put the moles here, and then subtract those moles from your original number of moles, and then you'll have some moles of your H plus left over, and then you're going to want to divide that by the new volume. So at 10 milliliters, I add 10 to 25, so the new volume is 35 milliliters. So whatever number of moles of H plus that's left over after you subtract out the reacted NaOH moles, then you divide that by the new volume, which would be 35 milliliters for the 10, 40 for the 15, and then 45 for the 20 milliliters. And then once you've got the concentration, then you put that into the pH equals the negative log of the H plus concentration, and that's going to give you the new pH. And so I have those calculated over here. So those are going to be, so those and I'll write them here. So 1 point, oops, lights. And so here, the pH is going to be 1.37. So 1.37 for the 10 milliliters, 1.60 for the 15, and 1.95 for the 20 milliliters after adding 20 milliliters of my NaOH. So that would be, let's say, so here we are at, so 1.37. So maybe that's here. And then we have the 1.6. So maybe that's here. And then we have the 1.95. So we're getting close to 2. So maybe that's there. And so this is our graph so far. So you can see that the pH is increasing a little bit because we're adding some of our strong base. Okay, so what about adding the P after at the equivalence point here? So when we add 25 milliliters of our NaOH, we've effectively added the number of moles we need. So we have equal moles of our base, and we saw that 25 milliliters is what we need in order to add the same number of moles of base to the same number of moles of acid. And so what will happen is the amount of base we add, the moles of the base is going to equal the moles of the acid, and that's going to cancel out, and we're going to have 0 H plus left over. And so at that point, the H plus concentration of our solution is only due to the autoionization of water. That's what's left. So your acid is gone, your base is gone. The only thing you have left is water and some salt. And so the autoionization of water is going to be the only source of OH minus and H plus. And so since we know that the concentration of H plus at 25 degrees for water is going to be 1 times 10 to the negative 7, right? So for water, it's going to be 1.10 times 10 to the negative 7 is going to be the H plus concentration. And so if you take the negative log of that, then you get a pH of 7. So at the equivalence point, when you're titrating a strong acid with a strong base and you neutralize the acid at the equivalence point, it should be a pH of 7 since water is the only thing that's left. So at this 25 degree mark, or this 25 milliliter mark here, then the pH is going to be at 7. So here. So you can see right away that at the equivalence point, the pH raises quite a bit. So now you're up here. Okay, so that's at the pH. That's going to be the pH at the equivalence point, and that's always going to be the pH at the equivalence point when you are titrating a strong acid with a strong base. Anytime you do that, the pH at the equivalence point is always going to be the pH of water, which is 7. So at this point, I'll stop here. In my next video, I will continue. If you like my videos, please make sure you hit that like button, subscribe to my channel, hit that notification bell up there, and also put a comment in the comment section. Let me know what you think so far. And if you like my videos, if you have a comment or a question, put them down below, and I will answer them. Thanks for joining me, and have a great day.